Hello. Today I'm going to talk about heart rate variability indicators. In the previous videos, I explained the nature of HRV and its signal. Today, we'll focus on the measurements derived from the variation in time intervals between heartbeats. I explored the research paper titled Heart Rate Variability: New Perspectives on Physiological Mechanisms, Assessment of Self-Regulatory Capacity, and Health Risk, along with its reference studies. The topics we'll cover are RR-NN, SDNN, RMSSD, PNN50, and mean RR. I explained RR as the time interval between two consecutive R-wave peaks. While many RR intervals reflect normal heart rhythms, some can be anomalous due to various factors, which can impact HRV analysis. It has several causes. It could be ectopic beats. These are heartbeats originating from abnormal electrical activity outside the sinoatrial node. They can be classified as premature atrial contractions, early beats originating in the atria, or could be premature ventricular contractions, early beats originating in the ventricles. Ectopic beats can cause sudden changes in RR intervals, leading to irregularities in HRV measurements. Another cause of anomaly is arrhythmias. These are irregular heart rhythms that can cause variability in RR intervals. Common types include atrial fibrillation, rapid and irregular beating of the atrial chambers, ventricular tachycardia, fast heart rhythm originating from the ventricles. Another cause of anomaly are artifacts. These are errors in RR interval measurement due to external factors such as motion artifacts. Movement during ECG recording can introduce noise. Electrode issues. Poor contact or placement can lead to inaccurate readings. Anomalous RR intervals can distort HRV metrics, leading to inaccurate assessments of autonomic nervous system function. To convert RR intervals to NN intervals, one typically applies filtering techniques to remove anomalies. The NN interval is the time, in milliseconds, between two successive normal heartbeats. Given a series of NN intervals over a period of time, we can calculate the standard deviation of these intervals. This value is known as SDNN, and it reflects the overall variability in heart rate during the recording period. RMSSD stands for the root mean square of successive differences between normal heartbeats, NN intervals. It is a time domain HRV metric that primarily reflects short-term parasympathetic, vagal, activity. PNN50 is the percentage of successive NN intervals that differ by more than 50 milliseconds. It is another time domain metric of HRV and reflects short-term variations in heart rate. Like RMSSD, PNN50 is primarily influenced by parasympathetic activity and is commonly used to assess autonomic nervous system function. To calculate PNN50 we do the following. Collect a sequence of NN intervals. Calculate the absolute difference between each pair of successive intervals. Count how many of these differences are greater than 50 milliseconds. Divide this number by the total number of interval pairs. Multiply by 100 to get the percentage. Mean RR is the average of all RR intervals or NN intervals if excluding abnormal beats over a period of time, measured in milliseconds. In other words, mean RR represents the average time between heartbeats. The formula is mean RR equals sum of all NN intervals divided by number of intervals. Let's apply this to our example. Suppose we have a list of NN intervals. Like this. We first sum all the NN intervals. Then divide by the number of intervals to get the mean RR. From this value, we can also calculate the average heart rate beats per second or per minute for that interval. Thanks for watching. I will be back with more mathematics on HRV. This is Well Guru. Goodbye.